Alrighty, today's lesson is on the structure of an atom. So this is Chapter 4, Section 2. If you recall from the other day, we were going over Section 1 and 3 combined together, so you would have had your note sheet for that. When we're looking at the structure of the atom, this should be very familiar to a lot of you. You probably have learned this before. There'll be a little bit that you probably don't know or haven't learned, and by the end, you should be equipped and prepared to work on your homework assignment. So that is the goal for today. Alright, so let's go ahead and begin. So as we're looking at the structure of the atom, basically what we're trying to kind of determine is the different parts. And so when we went through the models of the atom yesterday, we realized that the models kind of, each one would add in one of these smaller particles here, which we're going to give different names in just a second. And so if you were looking at this picture, first of all, which model of the atom does this more or less represent? Because it's kind of a combination of two if you think about it. Okay, so for the first type, I would say since it has these concentric rings, it kind of looks like what's known as the planetary model. So remember, who is the scientist that discovered the planetary model or came up with that model of the atom? Yep, exactly, Niels Bohr. And remember that Niels Bohr didn't actually know anything about the internal making of the nucleus. He just knew there was a nucleus because of Rutherford. But as you're looking at this, recognize that it does have both positive and neutral particles inside the nucleus. So this would also then be part of the electron cloud model, or specifically looking at what Chadwick discovered, because Chadwick knew then about the neutrons. Alright, so if I was to kind of remove some of these, I know that the positively charged particles in the nucleus are protons. Good. And so I know that the protons are going to be the positively charged particles. They actually will represent the atomic number, which is what we're going to look at in just a second. And then if I'm looking at these orange particles, I would say that these orange particles have no charge, and that means that they are neutrons. And combined together, protons and neutrons are actually called nucleons. And you can kind of, I mean, the name makes sense because if you're saying they're in the nucleus, then they are nucleons. Lastly, anywhere on the outskirts here in these energy levels, or in other words, in different orbitals as well, I know that these are negatively charged particles and they are your electrons. Alright, however, if I was looking at each and every single one of these together, so protons, neutrons, and electrons all combined, I would say that these all make up, there's a specific name we can call them, and they're not atomic particles, but they are smaller, so therefore that makes them subatomic particles. Alright, so at the bottom of the screen here you can see I did give you two bulleted items. The first one, it says the mass of an atom is concentrated in the nucleus, and so remember that this is due to Rutherford. Not due to him, but he discovered or came up with that idea. And the second one, it says the volume of an atom is determined by the space that the electrons move in around the nucleus. So naturally, if an atom only has like one energy level, which is what we're going to look at in Chapter 5, then I would tell you that it's probably not going to have a very large volume, or that atom is going to be a little bit smaller in size. But if you have a second energy level like this atom, you can see that it's going to take up a little bit more space. So that's kind of what this last bullet here is talking about, that the volume is going to be determined by how many energy levels ultimately the atom has specifically. Alright, so let's keep going. We're going to break down our protons, neutrons, electrons so that we can look specifically what each one would represent. So protons, we are going to be adding in like about 3 different items for each of these. So protons, what is their charge? Yeah, good. So their charge is positive, and each of them would just be a +1 charge. So if you had 13 protons, then you'd have a +13 charge. Okay. Second question, where are they located? So protons are located where in terms of the atom? Yeah, exactly. They are in the nucleus. Okay. So protons have a positive charge. They are located in the nucleus. The last one, which some of you may know, some of you may not know, what's the mass of a proton? If you had a chance, you could have looked it up in your book before the lesson if you really wanted to. I know that probably less than one of you would actually do that. So if you wanted to look tonight, then you can look through the book. Once again, this is Chapter 4, Section 2. There's a chart, I forget which page it's on, but it lists the proton, neutrons, electrons. It lists what their charge is. It lists what their mass is and everything. So what we're actually going to be placing the mass as is going to be 1 AMU. And so what does AMU stand for, do you think? The A should stand for something that we're talking about, specifically in this chapter. So the A stands for atomic. And if I said this is the mass of a proton, then that's the mass. And if we're saying it's specifically one of this, then I would say that it's a unit. So the units of mass in this case are going to be AMUs. Alright, so if I was looking at neutrons then, neutrons on the other hand, what's their charge? Good. So they have no charge. Or you could even say that the charge is 0. And where are neutrons located? Yep, in the nucleus. And lastly, what is the mass of a neutron, do you think? Take a guess. Almost. That one we're actually going to look at whenever we talk about electrons. This is actually also 1 AMU. And so you'll notice that protons and neutrons have nearly the same mass. It's actually slightly different, but when you round it out and use atomic mass units, then they are roughly the same. Like this one is like 1.675, say, times 10 to the minus 27 kilograms, and then neutrons would be like 1.67 or say 671, so it's like maybe 4 thousandths in terms of scientific notation, but it's times 10 to the minus 27, so that's like out 27 decimal places, and that's the difference. So there's really not much of a difference between the two of them. Alright, last thing then for electrons. What is the charge of an electron? If we got positive charge, no charge, that makes this negative charge. And each one is going to be a -1 charge. That's going to be important when we get to the last slide of today's notes. Okay, where are electrons located? Are they located in the nucleus? You could use a couple different terms here. You could say it's outside the nucleus. You could say in the electron cloud. You could say it's in energy levels. I'm just going to say outside nucleus, so it encompasses all of them. Okay, and the last one, what is the mass of an electron? Yeah, actually, if you look at the picture, and if we went back a slide, you would see that they tried to do it a little bit here, but notice the size of a proton and neutron compared to an electron. So electrons are really tiny, and they actually are about 2,000 times smaller than a proton or neutron. So therefore, because they're almost 2,000 times smaller, we say that they are more or less 0 AMU. So they have no mass, or they are massless in terms of atomic mass units. We know that they do have mass, but it's so small compared to the other two that it's not going to affect the atomic mass as much. Alright, so once again, that was charge, location, and mass for each of those. Okay. So now we get to, you'll notice that we're just running through a lot of terminology here. We want to kind of cover all this terminology because when we get into Chapter 5, when we're learning about the periodic table, it's going to be really important to know what these terms are and know the difference. And so that's why I have this one set up, that we're going to look at the difference between the atomic mass and the mass number. So yeah, they both talk about this mass idea here, so it's in both of their names. However, they are slightly different, and we'll talk about why. Okay, so we're going to start with mass number. This is actually the one that we're going to be using majority of the time in class, just because it's going to make it a little bit easier for you guys, and we're going to be using nice whole numbers. So mass number is, ultimately, it's just the sum of the protons and neutrons. Okay. So if it's just adding up protons and neutrons, naturally if you had like 5 protons and 6 neutrons, then you would have a mass number of 11. So it's really easy to calculate the mass number. So that's the nice thing. So you could say this is easy to calculate. All right, on the other hand, the atomic mass is slightly different. What we're going to add on here is that this is actually a weighted average. Okay, so a weighted average, for those of you who don't know what it is kind of how some of your teachers might actually determine your grades. So let's say that you're in a class, and the class is solely based on just tests. So it's not like this class, because naturally you guys have homework and labs and everything else. And I would say that everything in this class is weighted exactly the same. So all the points are just points that we're going to add up by the end of the year. However, in this class, we're going to say that you have 4 tests in the class. You're going to have a midterm and you're going to have a final. Okay, so I would say that maybe each of the 4 tests would be 10% of your grade. So the first test will be 10%, second test will be 10%, and so on. So that would make up 40% of your grade just in those tests. That leaves 60% left for the midterm and the final. So let's say that both the midterm and the final are 30% of your grade apiece. So what's going to happen then is, in order to calculate your grade, you would take, basically for that weighted average, you would take that first test and you would add up that score. But since it's 10% of your grade, you're ultimately making it so it's like you're adding that test 10 times. And then anytime that you have the midterm or the final, since they're 30% of your grade, then you would use those grades 30 times. And so because they're weighted, then they're used more often because they have a higher percentage. And so if I was to find the weighted average of your grade, I would take, let's say you got an 80% on your first test, an 85 on your second test, a 90 on your third test, and a 95 on your fourth test. So if I added all those together, then I would get, anybody got their calculators handy? Nobody. Really? You guys should grab your calculators. You know where they are. They're on the side where the smartboard is, because you might need them a little bit later today. Go ahead. Get the calculators. Still waiting. Alright, so while the rest of you are grabbing calculators, I'll go ahead and get started. So if I was to, once again, add 80 plus 85 plus 90 plus 95, then I would end up with 350. Is that what you guys got? Okay. And so 350. So as I'm looking at that, I would know that 350 points is going to be all from the tests. But then let's say your midterm, once again, is going to be 30% of your grade. So let's say you got a 90% on your midterm. And so that's going to be 3 of those grades. So that's 270 points we're going to add in just because of that. So 270 and 350 is going to give us 620. So I'd have 620 total points. And then lastly, let's say the final, you didn't do as well and you got an 80% on the final. So therefore, that's once again added in 3 times. So we were at 620, so that would add in 240 points, which would give you 860 total points. And so then all I would do then at the end is we're dividing by 100, and in doing so, then that should give you roughly what your, or sorry, dividing by 10, and that should give you roughly what your percentage would be. So you'd end up with like an 86 in the class. So that's more or less what a weighted average would be. So that's kind of what happens with this atomic mass. So now we can get back to our discussion here. So with atomic mass, it's a weighted average of the isotopes. And we haven't talked about isotopes yet. So it's the weighted average of the isotopes of an atom. It's actually going to be the next slide. And so an isotope, let's go ahead and jump ahead real quick, because we're only going to add one more little thing on this one. So an isotope, that way you get your definition, you kind of get an idea as to what it is. Isotopes, and here's what you want to write, are atoms of the same elements, but they have the same atomic number, meaning that they're going to have the same number of protons. So you can see I put that in parentheses. The same number of protons for the atomic number, but they have a different mass number. And so if you remember from the slide that I was just on, the mass number is the number of protons and neutrons. So the protons you see, if I'm looking at, these are isotopes of hydrogen. Hydrogen here has just 1 proton, deuterium here has 1 proton, and tritium here has 1 proton. You might have heard of tritium whenever all those Spider-Man movies came out. They were talking about tritium as this valuable resource. That's kind of what they were looking at. So anyways, you can see that the first hydrogen has no neutrons, and so its atomic number is 1 because of the proton, and its atomic mass is only 1 because there's no neutrons to add to it. Deuterium has 1 proton and 1 neutron, so its atomic number is 1, but its atomic mass, sorry, not its atomic mass, its mass number is 2 because it has 1 proton and 1 neutron, and you're just adding those together. And the last one I can see has 1 proton, but it has 2 neutrons this time, so its atomic number is still 1, but its mass number is now 3. So that's what an isotope is. Ultimately, these are going to have different properties, and so what I would do is I would say that when I'm finding the atomic mass, this hydrogen probably happens or occurs, we'll say, about 98% of the time. And let's say this one only occurs about 1.3% of the time, which means that this one's only going to occur 0.7% of the time. And so ultimately you would take a weighted average using this as the percentage in terms of masses. So you'd look at, I'm going to do 1 times 98, and then I'm going to do 2 times 1.3, and then I'm going to do 3 times 0.7. And naturally these are just percentages I made up. I don't remember what the actual percentages are for these. And so you would then just add those up and divide by the number that you would have, and that would give you what the weighted average, or in other words the atomic mass, would be for these. So if you were to look at a periodic table, so I'll go back a slide. If you were to look at a periodic table, then you would see the weighted average on there, or in other words you would see an atomic mass. So if I was looking at the atomic mass of carbon on a periodic table, I would see 12.011. So it's not a whole number because this little decimal portion is due to the fact that you actually did a weighted average. Mass number, on the other hand, for carbon would just be 12, because I would say that there are, for a standard carbon atom, 6 protons and 6 neutrons. Okay? So therefore, weighted average atomic mass is going to be a little bit different than the mass number. Mass number is a lot easier to calculate. This one, you actually have to determine what the percentages of each isotope would be. So if you were in a chemistry class, you'd probably have to actually determine the atomic mass. I know that Mrs. Dotterer does do that in one of her lessons, and so you would actually have to determine the weighted average for some of those atoms. We actually will not do that in here. Alright, we are almost done, guys. So we have about 3 slides after. I'm going to go back to the isotopes just to make sure you guys were able to get that. So if you need to pause this to finish up writing at the bottom here, that would be great. Okay, so hopefully everybody at this point has this down. So once again, isotopes, they have the same atomic number, or in other words, they have the same number of protons. In this case, it's 1 proton for each of these, but they have a different number of neutrons. So 0, 1, or 2 in this case. Okay, let's keep going. So when we're looking at the structure of an atom in relation to the periodic table, so this is how these numbers are all going to apply on your periodic table. What you're going to see here is this is actually written in a different way than what you would see on your periodic table. This is actually reversed. A lot of times the number at the top is larger than the number at the bottom, but as long as you recognize which one is always going to be the larger number and which one's going to be the smaller number, you should be in good shape. Okay, so anytime you're looking on here, first of all, the O here, this is called your symbol. We're going to do this a little bit more on the next slide as well, so if you don't want to write it down on this slide, you don't have to just yet. If I'm looking at this picture, I can see the mass number is going to be 16. Since I know the atomic number here is 8, this is the number of protons, which means that, remember, mass number is the number of protons plus neutrons. So if I have 8 protons and I have 16 protons and neutrons, then how many neutrons would you have? And to find it, you would just take 16 minus 8. And so you can see that over here I got my mass number 16, but then check this out. My atomic mass is 15.9994. So you can see it's pretty close to 16, but it's not exact because, once again, it's that weighted average. Atomic number, once again, represents the number of protons, so these will always be identical. The electrons will be identical if it's not an ion. We talked about ions briefly when we looked at plasmas. So remember, ions are charged atoms, meaning it's going to have a positive or negative sign for the charge. Okay, if I looked at magnesium, I can do the same exact thing as I did just above for oxygen. So the atomic number is 12. It's the smaller of the two. It means it has 12 protons. This number represents the mass number since it's a whole number form. So this is going to be the number of protons and neutrons, which means that I also have 12 neutrons for this one. It's not always going to be the case where you have like all these being exactly the same. It just so happened to be that way for the two that I chose for here. Okay. All right. So like I said, this is where you're going to want to write some of this stuff down. So to calculate different things for an atom, here's what we're going to do. So first of all, if you have this notation here, you can see I called this isotope notation. So isotope notation, you have your mass number at the top, you have your atomic number at the bottom, and you have the symbol, which would be the, like C for carbon, or O for oxygen, or W for tungsten. Just kind of depends what you're using for that symbol. So I'm going to go ahead and move this over. So isotope notation means that you're always going to see the mass number on top and the atomic number on the bottom. Or if you're writing them in terms of symbols, you might see it like this, where the X represents the symbol, Z is always the atomic number, and A is your mass number. So it kind of goes from A to Z, if you think about it that way, from A to Z, top to bottom. Okay, and the last one, then I gave you an example here. So if I was to use this as my example, if I asked you what is the atomic number of this element right here? Yep, exactly. You guys can see that it falls. It's the bottom number here. The atomic number will always be smaller than the mass number, so the atomic number is 11. What if I asked you what is the mass number of this element, or specifically this isotope? Good, it's 23. If I asked you what the atomic mass is, you actually couldn't determine it from here because we don't know what the different isotopes are. And what is the symbol here? Good, it's Na. What does Na stand for? Some of you know it. Yep, nice, it's sodium. Excellent. All right, so therefore at the bottom here, you're going to want to write some of these things down. So if I'm looking at the bottom, I know that first of all it says that the number of protons plus neutrons is A. And remember that A is this mass number. So you want to make sure that in order to find the mass number, it's just adding protons and neutrons. The number of protons is just Z, so therefore all you got to do is know the number of protons, and that gives you your atomic number. To find the number of electrons in a neutral atom, that could also be Z. And the key here is that it's a neutral atom. Neutral meaning no charge. But if it does have a charge, then we're actually going to find the difference between the electrons and the protons, and we're going to do that on the very last slide. All right, and the number of neutrons, to find it, it's really easy to do, because remember, if the top here is the protons plus neutrons, and then I subtract out the protons, then I'm going to be left with neutrons. Check it out, these cancel out, so then I'd just be left with neutrons. So if I take 23 minus 11, then I get 12. And so it would have 12 neutrons. All right, so these are the kind of things we're going to be doing. You'll have some of this in your homework as well. All right, so the last thing, you'll notice that I kind of expanded this out a little bit, and so what we're going to be doing here is we're going to be observing this periodic table. However, you should have periodic table in your folder. It might be with your homework if you haven't already grabbed them. I did slip them into one of the folders in the back crate. I can't remember if I put it in this one or the next one, but you should be able to find periodic table. Each person can grab a periodic table, and you can use it on any test from here on out. Just you cannot write on it unless I specifically tell you that you can write something on it. So if there's anything written on it and you're trying to use it for a test, I will take it away and you'll be without your periodic table. So do not write on your periodic table. Alright, so what we're going to do here is we're actually going to determine the numbers that are missing and also technically the symbols and everything that are missing. So you see sometimes I gave you the actual elements, sometimes I gave you the number of protons, sometimes I gave you the number of neutrons, and so on and so on. And so if I'm looking at this, I know that, for example, if I wanted to find the number of protons, I know that that is also equal to the atomic number. So I could say that these are the same. Okay. Also then, if I'm looking at the element, I know that I can look at the periodic table and I would be able to find the protons. However, be careful. Don't look at the element and then be like, oh, so I know what the mass number is as well, because the mass number may change. I might have given you an isotope of that element. So whenever you're looking at the element, for example, iodine, don't just go to iodine and be like, oh, okay, I know what the atomic number is, and then I also know what the mass number is because that's what I see there. Okay. So if I'm looking at these, I know that the element iodine, let's find it real quick for you. Okay, so iodine has an atomic number of 53. So I know that the atomic number is 53 because I look on the periodic table and that's what I would find. The top number is a 53. That means that I also have 53 protons. So you're going to notice that these two columns are exactly the same. So if I wanted to, then I could just kind of recopy each of these every single time, and these two columns are going to match. But we'll go through one by one so you get a rough idea as to what's happening here. Alright, so I know that the number of neutrons is given to you as 74, and so to find, once again, your mass number, I would simply take the number of protons plus the number of neutrons. So I'd have 53 plus 74, which is going to give me a total of 127, and that is actually what it is on your periodic table that I passed out to you guys. So those numbers on yours would be the mass numbers. You'll see that they're all whole numbers for you. Alright, the hardest part here, actually we can go ahead and do the isotope notation. So remember, the symbol is I, the top number is going to be the mass number, so 127, and the bottom number would be the atomic number, so 53. Okay. However, to find the electrons, this is what's going to be slightly different. You'll see that this time this has a charge of -1. And so remember that the two that have charges, protons have a positive charge. There's a plus sign. Okay. And electrons have a negative charge, which means that if I have more protons than I have electrons, my number or my charge would be positive. But if I have more electrons than protons, that means that my charge would be negative. And so if I'm looking at these, I know that the protons can't change, because if the protons change, then I'll end up with a new element. So the electrons are the ones that are actually going to be changing. So if I have a charge of -1, then that means that I don't have 53 electrons, because then that would give me a charge of 0. So if I need to have a negative charge, would you say that I have one more electron or one less electron than the number of protons? Good, I gotta have one more. The reason I have to have one more, if I put a 54 in here, think of it this way. This is a -54 and a positive 53. So if I have a -54 and a positive 53, I add them together, I get a -1. So that's how you're going to always figure out what these charges are. Alright, let's go ahead and try and do the next one. So I'm looking for an element that has an atomic number of 36, because you can see the protons is 36. So I'm going to go ahead and write the atomic number of 36. So go ahead and look for an element that has an atomic number of 36. If you need help, it'll be in the far right-hand column. Yeah, good. So it's krypton. So krypton's symbol is Kr. So I'm going to go ahead and add that in over here, and actually I can put my 36, and oh, lo and behold, look at that, I gave you your mass number this time, so you could finish out your isotope notation. Mass number on top, atomic number on the bottom. Okay, so now the only things that we're missing is the number of neutrons, number of electrons. Do you guys remember from the previous slide how to find the number of neutrons? Yeah, exactly. So if I'll go back real quick. So if I'm looking at this, once again, to find the number of neutrons, it's down here on the bottom. I'm going to take my mass number and subtract off my atomic number. Okay. So I'm going to find my mass number of 84, and I'm going to subtract off my atomic number of 36. And when I take 84 minus 36, I'm going to end up with 48 neutrons. Alright, and then we're back to the electrons again. Remember, oh, this time the charge is 0, so that means that the negatives and the positives should be equal, so this is also still just 36. Cool. Alright, we're going to run through the other ones pretty quick here, just so I'm not wasting your time if you're getting this, and then if not, the repetition is really going to help you guys too. If you wanted to write these down, you certainly can. You can go onto the course website and you can kind of go to this screen of the video first before I start writing on it, and then that way you can kind of fill it in and see how well you can do with it too. Alright, so for the next one here, I can see that I'm not given protons, but I am given atomic number, so I know that I can put my 87 in here for the protons. Those are always going to be the same. The number of protons is the atomic number, or the atomic number represents the number of protons. I can see I'm given now protons and neutrons, so if I was to add those two numbers together, so 87 and 140, then that should give you the mass number of 227. And I can look at the number of electrons, which is 84, and the number of protons, which is 87. I can see I have more positives than I do negatives, so this is going to be a positive, and it's 3 more, so therefore it's a plus 3. Alright, and then you look at the number of protons or the atomic number. So I'm looking at the element that has an atomic number of 87, and that should be francium. So you're going to find that as Fr. So I can write in Fr. I can put my 227, and I can put my, where is it, 87 at the bottom. Cool. Alright, manganese, next one. So on your periodic table you could find manganese. Manganese should be in the middle area, so it should be in between like the two higher columns. You should be able to find it. Do you guys find it? Yep, good. Okay, so it's Mn, and so the number of protons is 25, and that means the atomic number is also going to be 25. Notice I'm not going to take the bottom number there of 55, because I actually gave it to you as 54. So I gave you an isotope of manganese. Alright, but I can find the number of neutrons now, because all I got to do is take 54 minus 25, and if I do 54 minus 25, then it should match what you guys got. Okay. Number of electrons is based on the charge. The charge is -2 this time, so how many protons you have? 25. So how many electrons do you guys have? Good, 27, because it has to be 2 more because we want it to be negative, and it's 2 more negative. Alright, and last thing, then I can just fill this in real quick. So it is 54 on the top, 25 on the bottom, and this is manganese. Alright, next one is going to go real fast. So number of protons is 16, so what element has 16 protons? Good, that's sulfur, it's just an S. I can see it has protons and neutrons 16 and 18, which means that this is not the one that's on your periodic table, because otherwise your mass number would have been 32. This time it's 34. Atomic number is 16. It's going to match the protons. And the charge, well, I have 17 electrons. I have 16 protons. That's one more of the negatives, so that means it's a -1. And we got 34, 16, and it's sulfur. See, this is pretty easy, right? You're going to have something like this in your homework, so if you need to come back and watch this again, you certainly can. Alright, let's take a look at the next one. I'm giving you the mass number, and I'm giving you the number of neutrons. So you got to use that to find, say, the number of protons, or to find the atomic number. So you can take 211, which is your mass number, subtract off the number of neutrons, and that should give you the number of protons, which comes out to 85. So then I would look for an element that has an atomic number of 85, and you should find it over in the nonmetal section, so on the right-hand side of your periodic table. It should be AT, astatine, and the atomic number is also 85. Okay, and then the number of electrons, this is a +2 charge, so therefore if I have 85 protons, I need less electrons and 2 less, so that'd be 83, and then I can fill in 211, 85, and AT. Alright. Next one is SM, so you're looking for SM. You're going to find it on the bottom. So kind of look more towards the bottom of the periodic table. You should be able to find it somewhere around there. Did you guys find it already? Good. So you're looking at samarium. And samarium's atomic number is, yep, good, 62. Let's go ahead and do the charge right now. So if I have 62 protons and 64 electrons, that means I have more negative. By how much? Nice, so -2. And this isn't going to change the mass number to find it. Remember, it's going to be protons and neutrons added together. So I can simply take 62 plus 89, and that should give you a total of good, 151. Alright, and so lastly I'll put in my 151, I'll put in 62, and I'll put in SM. Alright, last one. So number of protons is 80. You should be able to find this one. It's one of those elements that is a liquid at room temperature. So there are only 2 of them. If you're using your key or your legend on your periodic table, you'd be able to recognize that. You should find that in the lower left-hand corner. So this one is mercury. It is Hg. And number of neutrons we can do because we have the mass number and we have the protons. So I would take 199 minus 80, and that should give you 119. And then the number of electrons, I see it has no charge, so therefore it's just going to be 80 equal to the protons. And the atomic number is also going to be 80. Alright, and so then I can put in my 199, I can put in my 80, and this is mercury. Alright, so this is ultimately what you're going to be doing for your homework. You're going to be trying to recognize exactly how to add each and every single one of these things in. And if you have questions, you can always email me. Otherwise, come back and watch the video and see how it goes.